Hello and welcome to section 2.2. Here are the solutions for 2.1. Okay, what we're going to be doing is analyzing conditional statements today. Some big vocab words. A conditional statement has two parts, a hypothesis and a conclusion. So we're going to be dealing with if and then statements. If this happens, then this happens. Okay, so conditional statement is a logical statement that has two parts, our hypothesis and conclusion. When a conditional statement is written in the if-then form, the if part contains the hypothesis and the then part contains the conclusion. So here's an example. If it is raining, then there are clouds in the sky. Now, they don't always have to be true, but we're just going to practice writing those today. So the hypothesis comes after the word if, and the conclusion comes after the word then. So we're just going to practice rewriting a few of these. And sometimes you have to add words. So if you have to add words, that's okay. All birds have feathers. We need if and the then in there. So I'm going to say if the animal is a bird. So I'm adding the words the animal. If the animal is a bird, then, so I need these two words, if and then it has feathers. And this may or may not be true. You might be able to come up with a counterexample. That's okay. Two angles are supplementary if they are a linear pair. So here they already have the word if. So I'm going to rewrite this as if, I'm going to start with the if part. If two angles, and you want it to flow. You want it to make sense. I don't want to say if they are a linear pair, then the two angles are supplementary. I want to say if two angles are a linear pair. So reread the sentence after you write to make sure it actually makes sense and it flows. If two angles are a linear pair, then they are supplementary. So a little bit of English here, grammar. Alright, so there's a couple rewriting statements in the if-then form. The negation of a statement is the opposite of the original statement. Notice that statement 2 is already negative, so it says negation is positive. So the ball is red goes to the ball is not red. The cat is not black. If we negate that, the cat is black. So it's kind of like a double negative in English class. They can be true or false. To show that a conditional statement is true, you must prove that the conclusion is true every time the hypothesis is true. And just like before, to show that the conditional statement is false, you only need to give one counterexample. So we're going to be proving things later on. Right now, counterexamples we're pretty good at. Converse. So there's three other ones after the if-then. So we have the conditional, that's the first one. And then there's three others. The converse, you exchange the hypothesis and the conclusion, and I'll do examples of all these. And the inverse, you negate both the hypothesis and the conclusion. The contrapositive, you write the converse, then negate both the hypothesis and the conclusion. So the contrapositive is a combination of these two. You're going to switch it around and you're going to negate both of them. Okay, so here's an example for you guys. If the measure of angle A is 99 degrees, then A is obtuse. So that's the conditional. And like I said, some of these might be true and some of these might be false. Converse, we're going to switch it around. So if angle A is obtuse, then the measure of angle A equals 99 degrees. And this is false. The inverse, we're going to negate both the hypothesis and the conclusion. If the measure of angle A does not equal 99 degrees, then A is not obtuse, also false. And then the contrapositive is a combination of these two here. So we're going to switch it around and negate them. So if angle A is not obtuse, then the measure of angle A cannot be 99 degrees. That is a true statement. Write the if-then form, the converse, the inverse, and the contrapositive of the conditional statement. Guitar players are musicians. Decide whether each statement is true or false. Okay, so Okay, we might have to add some words here. So I'm gonna start with my if then. If someone is a good guitar player, so I'm adding the word someone. If someone is a guitar player, then they are a musician. And that is a true statement. Okay, for the next one, we're going to work on the contrapositive. Okay, so what we're going to do is we're going to do some negations here. Or sorry, the inverse. So we're going to flip them around. Contrapositive, we're going to, converse, excuse me. Converse, we're going to switch them around, inverse negation. Alright, so converse, right, converse here. Okay, so if someone is a musician, then they play the guitar. And that, of course, is false. They don't need to play the guitar. Alright, for the next one, different color here. Now we're doing the inverse, so now we are doing the negations. So if someone is not a musician, then they don't play the guitar. Some of these get kind of tricky to think about. I actually have to think about some of these. So if I am not a musician, then I don't play the guitar. Okay, that's true. Because if I'm not a musician, it means I don't play any instrument. So and the last one is the contrapositive. I should use blue here. Use my last color. So contrapositive. And here we have to do the inverse and the converse. So we're going to combine the last two. If someone does not play the guitar, then they are not a musician. And I believe this one would be false, because let's say I play a different instrument, such as the banjo, then I could still be a musician. So I'd go with false on that. Okay, you can rewrite a definition as a conditional in the if-then form, or as its converse. Both the conditional statement and its converse are true. For example, consider the definition of perpendicular lines. If two lines intersect to form a right angle, then they are perpendicular lines. The definition can also be written using the converse. If two lines are perpendicular, then they intersect to form a right angle. So both of these statements are true. So you can write line L is perpendicular to line M. So when both the original statement and the converse are true, you have a definition. Alright, and then biconditional, I believe I missed something here. Yes, biconditional, I thought I missed something there. When a conditional statement and its converse are both true, this is what is called the biconditional. And we use the phrase if and only if. And they're written a little bit differently. And like I said, any valid definition can be written as a biconditional. So, two lines, let me go back. Two lines are perpendicular if and only if they intersect to form a right angle. Okay, so two lines are perpendicular if and only if they intersect to form a right angle. Now, two things to notice here. One, I did not use if and then. So there's not an if here. If, that's not there. Then, that's not there. Okay? And I have the phrase if and only if in the middle. So that's how you write a definition. So if the original statement is true, right here, and the converse is true, you can write a definition. There is your assignment. It is a lot of writing, just to be clear. You're going to be writing a lot of sentences. So we'll practice this in class. I'll do another example with you guys. Thank you for tuning in.